So here's the first of three. See, here's part 2 and here's part 3. So 3 parts for kinematic equations, and I'm not going to insult you by just giving you the equations and expecting you to not know where they come from. I'm going to try to explain where they come from in these 3 videos. That possibly will give you a better appreciation for the 3 of them. So let's start off with an overview. The biggest single premise we have with all this is that we are experiencing a constant velocity. So what does constant velocity mean? Well, what it means is this, your velocity will either increase or decrease by the same amount each second. So there is a constant rise or fall in the magnitude, unless you're turning, and we've talked about that in class. Don't worry about that yet. We'll get to that when we get to uniform circular motion. But for now, 2 things can come out of that. One of them is this. Actually, the biggest one is this. If we want to know our average velocity, this bar here means average. It's not a vector symbol, it doesn't have an arrow, it means average. Since the change is consistent, it turns out that if you want your average velocity and you know your initial velocity and your final at some later time, then your average is literally the average of those 2 numbers. And how do you average 2 numbers? Well, you add them together. So this would be, of course, your final velocity some later time. This is your initial or starting velocity. You would add them together and divide by 2 because you are literally finding the average. This actually won't work if your acceleration isn't constant. Now, the other thing that we know about average velocity, and this would be true regardless, is your average velocity is your displacement divided by your elapsed time, your change in time. Well, that means, if you remember displacement, that means our average velocity is going to be our final position. When we're working with the kinematics, we don't put a final there, we just leave nothing there. That indicates our position at the later time, minus our initial position divided by time. So with constant velocity, we're allowed to assume that right there, and of course this would be true regardless. And what that means is our average velocity, well, it should be the same average velocity for a given situation. So there's really 2 ways to look at the same quantity, which means we can set this and this equal to each other. And that means that our initial velocity plus our final divided by 2 is equal to our final position minus our initial divided by the time elapsed. Just keep that in mind or put it off to the side. As we go through the videos, we're going to reference this, we're going to use this fact a couple different times. But for now, to get our first kinematic equation, if you've done the reading and you've looked at it, you already know what acceleration is. Acceleration, of course, is the change in velocity divided by the change in time that change takes place in. This is your acceleration. That means acceleration is equal to, well, change in velocity. Anytime you see change in, it's a final minus initial. So it's your velocity later on minus what it was at the beginning. Notice a trim there with final minus initial, divided by the time it takes. Now, you've probably seen this in the notes on the Khan Academy or wherever else. This is actually, believe it or not, this is the first kinematic equation. We don't write it like this when we usually use it, and when you look at your equation sheet, it won't show up like this, but it's just a matter of the algebra. We're going to solve this for final velocity. So let's multiply both sides by t. Multiply both sides by t. And that's going to give me acceleration times time equals final velocity minus initial. Next, I'm going to add that initial velocity to both sides. Now, of course, over here, you really can't combine those two. They're different terms. So we just end up with acceleration times time plus initial velocity is our final. And I'm just going to reverse the order here. I'm going to write final velocity is equal to your acceleration times time plus your initial. Well, this sort of makes sense. This right here, right, is your change in velocity. So it's whatever you had plus however much it changed by, that change times time. And I think in your equation sheet, since it's one-dimensional, they just pick a dimension, they use x. So they would write v sub x, the original. Truth is, it could be y as well. It's just one-dimensional right now. So you could choose x, you could really choose y, you could really choose any letter if you wanted. But this is our first kinematic equation. And when I'm in a hurry and describing things as we go, I will oftentimes refer to this as the first. I'm not saying that's its official title, but it's what, if I say that, you can assume I mean this particular equation. And last thing, what two quantities in here are the variables and which quantities are initial conditions that can't change? Well, I can't change how fast I was going at the start. No matter what I do later on, I can't change an initial condition. So this would be an example of an initial condition. This is not a variable. And since we're dealing with constant acceleration, once we get an acceleration, it's not going to change. We're just assuming that right now. In the real world, that's possible, but for us, we're going to not go past that level of confusion, so to speak. So this is an initial condition. That means our two variables here that this equation relates, and this would be important to note, are our final velocity and time. In fact, the way it's written now, you would say it gives us the final velocity as a function of time. But either way, you could obviously, if you wanted to solve this for time. But these are the two variables that it relates.